This is the second of two videos on the properties of sampling distributions, of how samples behave, and their characteristics when we sample from large populations. And again, just to remind you from the first video that whenever you see the notation, either what I'm doing here or on your formula sheet with capital N and then mu and sigma, that's math shorthand for your normal distribution. Now, we're going to talk about properties of the proportions data type. That's what this one's about. There are only three properties that we need to concern ourselves with here. And we're going to do we'll start a new page for this one. And let's begin. Property number one is exactly the same as property number one when we were talking about mean values. If I take the average of repeated samples, so mu of p hat, this will be centered at p, which is an easy interpretation once you know the property number one from mean values. This simply says that the sample proportion equals the population proportion. So if I said to you, my sample proportion is 37%, what do you expect the population proportion to be? Well, 37%, just as simple as that. Of course, there's always going to be a little bit of difference, and that's where property number two comes in. So theoretically, they're the same thing. But there's always going to be a little bit of a spread, and that means we have the standard deviation of p hat. And this is a square root. Standard deviation of p hat is the square root of p, your successes, times 1 minus p, which is your failures, all divided by n. Simple as that. Again, the 10% rule applies. If you sample too large from a small population, of course, these things get out of hand. But for most populations, that's pretty hard to do. Point number three takes the place of point number four that we saw on mean values. How do I know that my sample is large enough such that it follows a normal distribution? And we use what's called the 10-10 rule. So let's write this out as for any sample to be approximately normally distributed. I'm going to use the shorthand notation for that, where here we have p and the square root of p, 1 minus p over n. So again, this is center, this is spread. So for any sample to be approximately normally distributed, we need a minimum of 10 success conditions and 10 failure conditions. And I'll do an example of this. This is called the 10-10 rule, and it is on your formula sheet. I'll just bump this up a little bit. So mathematically, that's n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So let's illustrate that with an example. Here's a new page, just to give us some room. Let's say we have n is equal to 30, and p is equal to 0.40. Well, let's see what we get. So that also means, by the way, that 1 minus p is equal to 0.60. So np greater than or equal to 10. Now that's pretty obvious that that's going to be true, because here's 30 times 0.40. Well, that's equal to 12, and that's certainly bigger than 10, so that's a success. Now we could say, well, 30 minus 12 is 18, which is also bigger than 10. Or if you want, we can go n 1 minus p greater than or equal to 10. So again, this is 30. I know I'm kind of dragging this out, and I apologize, but sometimes a detailed example is better than one where you know that everybody gets it, and that doesn't always work out. So this is equal to 18, which of course is bigger than 10. So here's a case where everything works out. Our sample size of 30 is sufficiently large to have a normal distribution. Now, that's an artifact of the fact that p is pretty close to 50%. The further p gets away from 50%, the bigger sample you're going to need. And let me illustrate that. Let's change this now. Let's see, now let p equal 0.25. Okay, that works. We'll leave the sample size the same. So now we have, okay, what's going on there? Let's just get rid of that. We'll put that back on there. I'm just going to write now. There we go. I must have hit the button on my stylus. No matter. So n is 30, and we're going to multiply that by 0.25. Well, that's only equal to, well, certainly not equal to that. Not by a long shot. That's equal to 7.5, or even if we rounded that up to 8. And this is less than 10, so we're stuck. That's not big enough. So even if we were to check the other computation where we'd have 30 times 0.75, this would be equal to 22.5. This one's bigger than 10, but the problem is this one. They both have to be bigger than 10. So as the proportion gets away from the 50-50 split, your sample size has to get larger and larger. And this is called the 10-10 rule. And that summarizes the three conditions that you need if you are checking for checking for the assumption of a normal distribution for proportions. And that ends this video.